On the other hand, this question, you gotta be carefully checking things out. I highly suggest that sometimes you really need to count the number of carbons. What you see here is you have an alcohol that's starting from, and then that becomes an amine. So we have to convert alcohol to an amine. But it can be done in many different ways. First of all, just like the alcohol can get good living with once you make a toastlaster. You toastulate that. Then you can make an amine by heating with a different types of nucleophile, like a sodium azide. Azide, you replace the toastulate, then you get an azide. Azide can be reduced by the hydrogenation or the lithium hydride, then it will becomes an amine. So you converted alcohol to the amine, but you notice that this and that is not exactly the same. It's a one carbon longer. Sometimes you can do transformation, but you forgot to analyze that. Oh, I just have to add one more carbon to it too. So then how are you going to do it, right? You have to add a carbon. And converting oxygen to nitrogen. So this is where the back of tree helps. If you've got an index card, prepare the variety of reactions, if you know them well, you should remember that nitrile, if you reduce that, it becomes a CH2 and H2. So maybe that CH2 and H2 can come from the nitrile. Then instead of the azide, if you're using a nitrile and cyanide to replace the toastulate, then you can make the nitrile the right number of the carbon. And then you only need to reduce that to like a lithium hydride, then you can make an amine with a one carbon extension. So that is something that you need to do. So instead of cyanide, definitely nucleophile. Heating this toastulate, make that reduce, and you can make it out. But if you're using a wrong nucleophile, then definitely you can convert the amine alcohol to an amine, but not the same number of carbons in the chain. It can be done with a halogen too. I mean, somehow you hate the toastulate, and it's okay. You can use the halide. You know how to convert an alcohol to the halide. If it's a bromide, you can use a PbO3. If it's a chlorine, you can use a PCl3 or thiamine chloride. You got choice of the reagents. So you can either do alkyl chloride, you can either do it alkyl bromide. I personally prefer bromide because bromide is a better living with a chloride. It's a more reactive, something you should know by now, right? It's less than two reactions. It's something that leaves better, it makes it go better. So, toastulate works too. This way, fine, that way is fine. In either way, you can make it happen. This is a pretty obvious answer. Instead, there are other ways to make it happen too. Let's say you convert this bromide and then you treat the magnesium, you can make a green ion. Then, this is kind of something that we didn't talk about it, but you can also imagine that. If you're using the formaldehyde, then you make an alcohol, but if you're using an imine has a double bond with nitrogen, it behaves like a carbonyl. So if the Grignard makes an append to the imine, then it opens up and you can make an amine too. But where the imines are coming from, that's basically formaldehyde and ammonia put it together, then you can make an imine. So this also works too. If it's a formaldehyde, you're reacting with the Grignard, that will make an alcohol, but we don't want an alcohol, we want amine. I mean, of course, once you get an alcohol, you can convert that with an amine later, but imine can be formed and being used in the Grignard. And you can also make an amine this way too. So this is kind of a question to you. How do you make that one? The difference is it has a 2 carbon extension. With a 1 carbon extended out, you have to use it like a nitrile or some other way. What if you have a 2 carbon extended, then what would you use? This is something that you need to think about. Kind of relate to this question. And there are easier ways to think of it. I don't know which answer you're going to come up with. But it's something you can do. Just think about that. All right, moving on. These are alcohol converting to the ketone. But you can easily see that number of carbons are different. So something got to be added to some somewhere. How do we make this happen? We have to make a ketone in the end, right? We have to make a ketone. So this is a 1, 2, 3, 4, 5, 6 carbon. Hexane is up to this point. So that means that we have to add in these portions. So how do you add that one? That's the question. So the reaction that makes a ketone, that you kind of completely through your mental notes. And then I hope you remember that if you have a dicuprate acid chloride, you can connect these two together, right? This is kind of one of the ways to make it happen. Then you need to make this dicuprate with a 6 carbon chain, which is simple. You need to have a halide. You cannot do it without. So you have to convert that with an acid, like the alkyl chloride or alkyl bromide. That can be done by the PL3 or PCl3, then you get the alkyl bromide there. You treat the lithium. First step is to make organic lithium. Second step, treat the cuprocyanide. You make a dicuprate. Then to that, you add the acid chloride. Then you can make a ketone. But there is another way. I bet you don't remember these reactions. That's why these reactions are, you really have to put some effort to remember it. It's not obvious. I mean, this one is kind of not easy either. But at least that you see the carbonyl of the acid chloride, you can imagine that must be coming from the acid chloride, connecting with this carbon chain that's of that recuperate. So you got the resemblance there. But this reaction has no carbonyl in the starting materials at all. This is nitrile. But I told you nitrile can be used to make a ketone. So that's why I told you that chemistry is something that you really have to put the map for to remember. But that nitrile add a carbonyl, so that's why, I mean, this nitrile part, that's the one becomes a carbonyl here. So you got the Grignard attacking this nitrile, then you can make this one ketone possible. This one made from this alkyl bromide by just adding on the relations. So Grignard made from the alkyl halide, then that reacting with the nitrile, then these attacks there, and then this carbon becomes that carbons, and then imine hydrolyzing we have to get a ketone.